In this video, we are going to look at the symbols for elements. We're going to look at diatomic elements, and we're also going to look at chemical formulas, okay? Okay, so this is a relatively easy concept, but I want to make sure we're all, 100% on this. So first of all, symbols are going to be for specific elements. Okay, these are the elemental symbols, what's on the periodic table, right? All of those symbols are for elements. And these are always going to be either 1 or 2 letters. And the first letter is going to be a capital. The second letter will be a lowercase if it has a second letter, okay? So I'm sure we're all pretty well versed on element symbols, okay? But for example, carbon has the elemental symbol C. Calcium is Ca, okay? C lowercase a, right? I'm sure you can just look at your periodic table and see all of those element symbols, but just be really careful about your upper and lower cases, okay? Make sure that the first letter is capitalized, the second letter is lowercase, all right? I guess fun fact, most elements their symbols are from their English names, like this makes sense. Calcium is Ca, carbon is C. There are a couple of weird ones, I think 11 of them, that do not have their, English name abbreviations. Most common one that's missed is sodium, is Na, which used to be natrium for its Latin name, right? So just be wary. There are a few of them that we will use often that, there's no N in sodium, so don't get confused, right? Potassium, that's another one. Potassium is just a K, all right? So just keep your eye out for those, all right? There are diatomics, all right? So there are diatomic elements. There are 7 of them. And the way that I was taught to remember them when I was remembering this was have no fear of ice cold beer, okay? You can come up with your own way to remember it, but that is how I remembered it. Have no fear of ice cold beer. All right, so H would be for hydrogen, N is nitrogen, F is fluorine, O is oxygen, I is iodine, C is not carbon, C is chlorine, so ice cold beer, okay? So the last 2 are gonna be chlorine and, what kind of B is that? And bromine, okay? So all diatomic means, di means 2, it means that these guys come in, it's a package deal, right? So there's always, for these ones, there's always going to be 2 of them bonded together. So if I was going to, draw a particle model of it, right? Fluorine has 2 fluorines bonded together. So just be wary that the element symbol for diatomics, you're still going to have like the actual elemental symbol of hydrogen, right? The elemental symbol is H, but anytime you have any kind of, chemical reaction or any kind of practical, spelling is fantastic, okay? Any kind of practical application of hydrogen, you're going to use H2 because it's diatomic. So if you had a chemical reaction, you have, oxygen plus hydrogen reacts to make water, okay? You're going to be writing your hydrogen as H2 in your chemical reaction. So learn these, memorize these. It's key to make sure that you know your 7 diatomics, okay? Hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. And if you look at your periodic table, here's my beautiful picture here for you, okay, of a periodic table. They're all in a really nice area for you to notice, okay? So hydrogen is up here, up top, and then you're gonna have this row that goes across like this and down like this, okay? That's where they all are. if you're looking at your periodic table, you should be able to find your diatomics very, very easily, okay? All right, on we go. Okay, chemical formulas. All right, chemical formulas is just a way to show you, all right, how many, so the number of atoms, the number of elements in a compound, and the type of elements in a compound, all right? So it's just a notation. So the symbol is going to tell you the type, and then the subscript is going to tell you the number of elements. And you intuitively know this, okay? And this will be the symbol. So for example, water. Do a nice easy one. Everyone knows this is H2O. So the chemical formula for water tells me a bunch of stuff, right? It tells me what type of elements are in my compound of water. I have hydrogen and oxygen in water. Here we go. I have both hydrogen and I have oxygen in water. And then my subscripts tell me how many of each atom I have. So I have 2 hydrogens. There's no number next to oxygen, right? Subscripted after oxygen. So that means there's only 1 oxygen. All right, 2 hydrogens, 1 oxygen, total of 3 atoms for that compound, okay? Hopefully relatively easy, all right? I have a bunch of examples, but I know you are on it and you get it, all right? I do want to make sure that you are, again, careful with your upper and lower cases, okay? So if I wrote COCl2 versus COCl2, okay? So this would be cobalt 2 chloride, okay? Cobalts with 2 chlorines. This is carbon, oxygen, and 2 chlorines, all right? So please be careful of your capitalizing and lower cases. It will really change the compound and what you're working with. It will change all kinds of things, okay? So just pay attention. This, just so we would know, right, there would be 1 cobalt and 2 chlorines. This would have 1 carbon, 1 oxygen, 2 chlorines, okay? All right, there are things that are slightly more difficult with chemical formulas that have a parentheses. These are called polyatomic ions. You're gonna have to memorize a lot of these, so yay, all right? But there are things with parentheses. So if I had, for example, this, okay? Magnesium, NO3 is nitrate. You can find it on your common ions page. You're gonna have to memorize it. Nitrate, all right? So this is called magnesium nitrate, and it's saying I have 2 nitrates. I have 2 of whatever's in these parentheses, okay? So if you had something like this, you have, right, 1 magnesium. There's no subscript after the Mg. And I have 2 nitrates, right? I have 2 of whatever this group is. So I have 2 NO3s, which means I have 2 nitrogens and I have 6 oxygens. Okay, if I was going to draw this out, right, here's nitrogen attached to 3 oxygens, okay, and if I had 2 of those things, oh, my beautiful drawings, I am so sorry, you're going to get used to them, I promise, okay, but I have 2 nitrates here, so I have 1, 2 nitrogens, right, and I have 1, 2, 3, 4, 5, 6 oxygens, right? Which would mean I have a total of 1 magnesium plus 2 nitrogens, 6 oxygens. I have a total of, what's that, 9 atoms total in this beautiful compound, okay? I think it's really easy to just think like distributive property in math. Who knew? Math, algebra, it actually comes in handy, right? So you can just distribute, right? So 2 times 3 is going to be 6 oxygens. 2 times 1, because there's no subscript after the nitrogen. There we go, right? So 2 times 1 is 2, and you have 2 nitrogens, all right? So there you go. Symbols, formulas, that's the basics. Woo, we're done with chapter 1. All right.